get started. Couple of announcements before we get going with the meeting proper. I think many of you may already be aware, but if you're not, there is this TWIML Fest that's being organized by the TWIML folks, including many volunteers who are hosting the various study groups and so on. This is an ongoing online conference slash celebration slash just meeting, hanging out, discussing relevant topics, panel sessions, ask me anything type of sessions, various people presenting on potential projects that they are working on, things like that. And if you haven't already registered for it, would encourage everybody who is a participant in the group and even tell your friends to join in. It's between the 13th and the end of the month. I think events are spread out over multiple days. There are a couple of keynotes, one by Jeremy Howard and another by, I think, Sal Khan of the Khan Academy. And then there are invited projects, panel discussions that one of the regulars in this group, Mehul, is having on medical AI or AI in medicine, for example, with panelists from Intel, National Institute of Health, and so on and so forth. So that would be, so there are many such interesting events. The timings and other things will be published in due course, but if you haven't registered for it, if you go to the general channel, I'm sure you'll see multiple invites to register, and I would encourage all of you to register. It's actually more from for the various participants. That's kind of for our benefit, and so the more of us that join in and participate or contribute and or benefit from it, that would be great. The second announcement I had, wanted to mention it here, take any questions and then post it on the channel, is at the request of Joseph and myself, TWIML folks have decided to try and migrate to Discourse as the forum for a lot of the discussions and the study groups. So they are piloting that change. You would have already seen announcement if you're also a participant in the hands-on machine learning group from Joseph. I'll send out a similar announcement to this group. I just wanted to mention it. So essentially, I think, and Joseph, please chime in if I get the details wrong, but it's my belief that once I post the link and you can join in, it'll ask you to sign in, set up a password. After that, it's, if you've used the Fast AI forums, it's essentially similar in many ways to things posting on Slack, except that the data never goes away. So, it's maintained even over years. So for example, the earlier data on a lot of the segmentation things that we had discussions about on this group around the OSIC, around the Celestial Steel competition would all be maintained rather than getting lost after a while if it's on Slack. So you will see a post from me and an invite that you can just accept, click, and provide the password or create a new password if you wish, and then get enrolled into the Discourse forum for the Kaggle group. And that will enable us to save all of the links and or any of the discussions, posts, things like that get saved over time and don't disappear at the end of several months. So that's something else I wanted to mention. And any questions regarding that? At least for the short term, I believe we are not eliminating, or TWIML isn't eliminating Slack, but the goal would be that once all the study groups and stuff move on to Discourse, then eventually not have two forums, but just migrate and to Discourse in the long run. Any questions on either of those topics from anyone? Sorry, was there a comment or question? Okay, if not, let's move on to today's main focus, which is the Quora question answering Kaggle NLP challenge. Anybody made more progress and want to present? I personally have not made much of a progress other than looking at a couple of EDA and a couple of approaches that have been suggested. So I wanted to share that, but I'll hold off and yield to anyone else who wants to actually share. Gautam, any further? Were you able to get a score on the universal sentence encoder? Would you like to share?
Actually, I didn't get much time last week, so no updates really. But I attempted to submit my Excel, but I still failed for some reason. I didn't really try. But one question I had was, so the error that I'm getting right now is I'm not able to get the same number of rows in the CSV that I submit. So I'm not sure if what the exact
Yeah,
issue is.
I had the same issue, Gautam. So what I figured is there are two things. One is the file they provide test.zip.
Yeah.
Zip file has, if you go if you open a file with the pandas, the zip file, it has more records.
Yeah. And there
However,
is a different test.csv, right?
yeah, so if you use the test file, then that has a close, that has exact number of records,
Okay.
and you don't need to delete the records. So I had the same issue. So if you have question 1 or question 2 missing, we were dropping it. I looked at it. I asked your collab book, so I was looking at it. So not to delete, drop them. So if you use exactly test or CSV, it will work then.
Yeah. And the Kaggle command line tool, if you use that to download the dataset, it does not give you the .csv, it gives you the zip files. So yeah, and I used those and I removed these duplicates and stuff like that, and finally the number of rows was less than what was required. So I'll have to
Exactly.
try
So
that
Exactly.
I
again.
see. So sorry. So the takeaway from what you're saying, Gautam, and what Dinesh you're saying is that don't, even if the rows are empty and or otherwise, don't change the number, or else your scoring, which expects those number of rows, will not work. Is that correct?
That's correct. That's correct. Yeah. And
And
the second point was there is a test.csv and there is a test.csv.zip. And if you read the zip file directly, I think it has a more number of rows. So that is going to fail as well. So there is a file only test.csv for whatever reason. And I'm not sure whether I have downloaded directly from the computation or from one of the the Steve has given that EDA book. So when I copied it
Right,
over,
right. So
I think
some other notebook or directly from the competition source file.
correct.
You're not sure where. Okay.
Yeah, correct. Yeah, and then
Okay.
once you
So
use
you're saying the test.csv should be downloaded. If you download test.csv.zip and unzip, then you unzip that to get the test.csv, then that unzipped file seems to have different number of rows than what the scoring module expects.
I didn't do the unzipping. I just read it directly on the pandas data frame and directly read it. But still, I got the more number of rows. So you're right that the zip file has for some reason more rows. Yeah.
Okay. And a question for you, Gautam. So in your case, you were saying that when you download it to Google Drive, then obviously it came in zipped, and when you unzipped and then submitted, that might likely give different files, or you unzipped it and then you processed the test and removed the duplicates, and you don't know which of the two reasons is the reason that it's failing.
Yeah, I unzipped it. Then that particular test data frame had a bunch of duplicates. I removed those duplicates, and some of them were nan as well. I think I removed those, and finally, when I submitted, it said the number of rows was less.
I see. I see. That's interesting because that's something we'll have to further detect whether if you downloaded, unzipped, but did not. I think if you fill the nans with empty lines, that shouldn't change it, but anything like eliminating duplicates, which changes the number of rows, then it seems to be causing a problem. Is that? But the more people who submit, and I think the test at least that I ran was on Kaggle itself using directly data, and it was a prior submission that had worked. Therefore, I assumed that I had navigated the challenges that we are actually, that Dinesh and you are actually encountering when we do it fresh. So that's good to know. I'll mention that in my summary when I write it up so that others are aware.
So just out of interest, in a Kaggle competition, when you have a test set, and so like in this instance, when we are looking at two questions to determine if they're the, how similar they are, and if one of them, so we're expecting as input two sentences. If your test set has only one sentence, how are you normally supposed to respond, or how are you supposed to provide a response to that? Because clearly it looks like you can't. Well, one is to ignore it, and it looks like we might have problems there. But typically, what's the expected response for something like that?
Well, I mean, you can have a variety of approaches, but a simple approach would be that obviously the two are not equal. So if one is a null, unless both are null, you just say that it's not a duplicate, right? You don't eliminate the row. The problem is in the elimination of the number of entries. So as long as you don't eliminate a row, and if one of the two question pairs is nan, as Gautam was saying, you can replace it with a empty string for string processing purposes if you wish. That won't change the number of entries, but then you can say if one of them is a null and the other isn't, then it's obviously not the same question. So you can say one way I'm saying of dealing with it is to just say that it is not a duplicate, unless both are empty strings, in which case it is a duplicate.
Yeah, understood. Actually, that was a stupid question. Apologies. Yeah.
Right, because that's, well, I mean, it's not, nothing is stupid in the sense of dealing with these things, but I'm just saying that that's a way to handle it, right? Without eliminating the entry. Anybody else? I saw Yuri just joined. Yuri, were you able to make any progress, any new submissions that you'd like to share?
No, sorry. So sorry I'm late. So I continued using the same sentence embedding, and I was like still doing like completely unsupervised. So basically just use pre-training. But I actually found that the same. So I just found actually the same software, and they have like really nice tutorial on how to actually train. Let me share it. Just a second. So this is the same sentence transformer that I shared last week, but this is they actually have really nice documentation. So they tell you how to do different tasks, and one of the tasks that they actually their training example is query duplicate questions.
Cool.
So they actually, what they do is they basically say, well, this small question is not, and I just read the tutorial. I haven't tried using this, but they basically say, well, for this specific question, you just for this specific problem, you just want to see if question 1 and question 2 is duplicate. But they're saying is like, well, in real life, you want kind of more, right? So they have this goal of question mining to find all the duplicates and find the closest sentence. So from what I understand, again, I just skimmed it. They came up with multi-goal training, and then they have 2 losses that they recommend. So this gives you like a way of training. So you can start with the same pre-trained model, and actually gives you way of training. So that's the next thing I want to try.
Like very directly fit to the problem, fairly advanced, such that it can do much more than even what the problem, what the desired goal for this narrow problem is, because it can do things like in the data set find all the questions that are similar to a question, rather than just say whether the 2 things are equal or not.
Yeah, I could not find if they basically solved the narrower problem at all. And I think maybe they did it by doing multi-training, but that's what I don't know yet.
Yeah, we'll have to use the model, apply it in this case, and I mean, and given the recentness of its using Siamese BERT and stuff, I would anticipate that it should get much better results. But that's the beauty of practical. Let's see what the results are, and let's see whether some of the best results that others got are still numerically better than this, or this beats those results hands down. So that'd be interesting, fascinating. Cool. This would be interesting to try.
Sorry, I just wanted to ask, can anyone give a summary for what that contrastive loss is?
Yeah, there have been interesting you said there were 2 losses, right? One is online contrastive loss, and the other one was what loss? There was
I found this morning. So
so we'll have to dig into multiple negative ranking
loss.
Interesting. So I think I'll add those 2 at least. If it's not explained, maybe we can spend some time in one of the upcoming sessions to dive into the detail of both those losses, because those are new losses that I've not seen before either, to Rek's question.
Okay.
I can provide a 2-minute overview of. So I unfortunately I went down a rabbit hole. So I'll spare you the details and show you. But I just thought there was a really interesting. Where is that? So there was this really interesting thing called the STS benchmark, which is where they have 2 sentences, and it's actually the results or the benchmarks actually set by people. So they get people to actually provide these results. And so I thought I would use this to help improve my model. So it's pretty interesting, quite easy to use, and they score things, so you can actually download the data from here, and they score the sentences between 0 and 5, 0 being they're totally dissimilar, 5 being they're pretty spot on. So I thought this would help me fine-tune my model, but there were a couple of challenges I ran into with some of the data here, and so I couldn't use this to fine-tune anything. But I hope to be able to do something with this. But it's cool. Nice, interesting data set here if anyone wants to take a look.
Yeah, best to both you and Yuri, if you can post the links on Slack that you referred to, that'd be great. So we can, and then right now post it on Slack. I'll provide the Discourse link, and once you join, sorry for the duplicates, maybe even I'll copy it and post it off in Discourse to start off. But if you can post it on the Slack channel for now, that'll be great.
Yeah, just did.
John, could you elaborate slightly on the issues that you were facing?
Yeah, sure. It was just some. I thought my pandas was up to the mark, but it was just really odd things like the CSV. Let me show. And this is probably why I wasted so much time on it. Oh, hang on a sec. So it's just really odd stuff like. So I was pulling. So I was grabbing the data, and I pulled it into my files, but like the dev. So there are 3 files. There's a dev, there's a test, and train. And when I was pulling the dev files, it was still. Here we go. So it's 1,468 lines here, but in the actual dev file, it's like over 100 less. So I just couldn't figure out what was wrong, and so it was things like this which made it quite annoying. Because I was hoping to be able to use this to help me with the thing. So I just couldn't figure this one out. You know, I mean, there's nothing, right? It's not empty spaces or anything, and I've got options to, skip blank lines, but I just could not make sense of. There's nothing. So it's just stuff like that, which made me. Yeah, just waste a lot of time trying to figure it out rather than spending time trying to work on the problem. So
I was just curious. Interesting. Cool. We'll check this out. Surely can add more data, and so
yeah,
that will surely help. Yeah.
Yeah, I know. I mean, I thought because it's annotated, right? It's annotated by people. I thought it would be really good data that we could use. Perhaps this is a little bit premature to look at this. Perhaps when you have a nice model, then you can work on fine tuning it with this data. But I thought this would be a really easy data set to use, and it turned out not. So.
Yeah, bringing in external data once you have the model, it helps. In this case, though, at least to my knowledge and from the EDA thing that Steve shared, and I'll kind of go to it in a minute here, just to stare at the numbers. The numbers are fairly large, like 400,000 pairs or something that is already there in the data set. So barring, things that Yuri pointed to, which would be going beyond the intended goal and kind of trying to find all duplicates, not just deciding whether 2 things which are provided are duplicate, but finding, duplicate of any of the 2 questions in the question pair and whether there are duplicates elsewhere and stuff that. But nevertheless, yeah, having annotated external data is always very useful once you have a good model built up. Yeah.
Is there any reason you're not using pd.read CSV up front? not to dwell more on this, just kind of curious if you have tried that and not used it, because I could see like on the left-hand side columns, you had sentences, the right hands were kind of empty, but you were doing skip lines. Just kind of, I haven't tried.
Read CSV as opposed to.
You were reading slightly different, right? Like from what I was seeing from your.
Oh yeah, no, it's the same thing. Sorry, hang on a sec. It's the same thing. I was using read table. Table has by default tabs, which is what the data had. So I could use a read CSV, and the separator would be a tab as opposed to a comma. Yeah.
Interesting. Okay.
So
okay,
one question I have. We are looking at the moment like sentence pairs, left to right, like one to one, and we said we're going to check the Jaccard score or the cosine similarity. So when you say we're going to go through the whole corpus to see if the question is duplicate or not. However, how are we going to mark it as duplicate against?
Yeah, no, sorry, Dinesh. I didn't mean to confuse you by saying that for this competition, all that is required is for us to decide and come up with a column of duplicate or not duplicate on each row of the question pairs. That's all this competition requires.
Correct.
So we can make a decision on a row by row basis and just decide that and give a binary output 0 or a 1, and a probability with a threshold will work as well. By that I mean, if you decide that if my probability is more than 0.5, then I'm going to decide that it is duplicate, and if not, then it's not. And of course, you can choose a different probability number than 0.5. You can even choose 0.4 or 0.3. I mean, that's kind of up to you. You in making the choice. But that's the only requirement of this competition.
Yeah.
That's it. And to make the decision, of course, we could use, like you were saying, distance. We could use a variety of parameters to make that choice. So that's all that's required for this competition. What I was referring to, and I didn't mean to confuse, so that's it. That's the end of what is needed for this competition. What Yuri shared when he shared the method or the approach in the link that he was showing, they said, okay, this is all that the Quora similar question or duplicate question competition requires, but in a general application, even for Quora or for any other entity which is looking to deploy something like this, let's say we develop a tool which just is able to decide whether something is a duplicate or not. It's on a row by row basis. We are done as far as this Kaggle competition is concerned. But what Yuri was pointing to and the method or the capabilities that that tool seem to have is to not only decide that the row by row, in fact, again, as Yuri said, you have to deploy it. You have to actually employ the tool, see whether it works for what he and I were referring to as a narrow problem, which is the problem that we are faced with on this Kaggle competition. But it seems to have the ability with this contrastive loss or other things and stuff to also be able to tell you whether, if you say, let's say we take 100 pairs, or in the Kaggle competition, we have 40,000 pairs. The tool seems to be able to tell us not just whether one row of two questions is a duplicate or not a duplicate, but it seemed to have the ability built in to be able to say whether, let's say, question one of a two-question pair is similar to any other question in any of the 39,000 other pairs, and things like that. But that's not necessary. That capability of that tool is not necessary for us to solve the problem that we face currently in this Kaggle competition.
Yeah, makes sense. Yeah. So on the same line, if we just say we focus on this competition. Last week we said we're going to check the cosine similarity and a jagged score. Do we have any other idea, any other, like what else we can compare the two embeddings to say, okay, this is the score, other than the cosine similarity? And the reason the reason I'm asking is that I was just looking what we can use. So I was trying to use the sentence encoder, which Gautam said, and then afterwards the one which Yuri gave as well. I was trying the same way, and I said, okay, this is the embedding given by this transformer model, but ultimately, how do I compare? I'm going to go back to the cosine similarity. So I was just thinking, from solving a problem perspective, what other aspect we can look at this pair? Is there any other ideas?
Sure. Yeah, there is one at least that I saw, and that let me jump to that particular thing directly, but it also leads us to at least what I was seeing as, obviously Gautam and Yuri have shared more advanced and more complete encoding capabilities built in that you can readily use. But sometimes I like to progress from the pieces so that we understand that better. And in fact, given that the post I'll go to in a minute when I share is from Quora itself, it kind of shows the thinking they went through, and one of those points to a slightly different approach in terms of judging the similarity, Dinesh. So let me go there and share. Can you folks see my screen yet?
Yeah.
Okay, so this, I just thought, as we are still in the early stages, let's look at, as Dinesh, you were saying, let's look at the ideas that people have done and see which of those we could implement, even starting from simple things. Of course, there are even simpler approaches than what this particular post talks about, but there are 3 ideas that are talked about in this post. One of them that I'll jump to directly, which is actually, I believe, the second one, and then we can go to the first and the third, because the second one addresses directly the question that you raised of, is there a better way than just cosine distance? So just to set the context, they were just trying, they being the Quora engineering team itself, and remember this is in February of 2017, so it was about, close to 4 years back. And they just posted the public data set that we are staring at now. And they're saying, they tried that, or even stepping back further, they originally had handcrafted ways to do what they were tasking the Kaggle competition with doing. They had handcrafted features that would help them determine what they were asking us to determine. But they were moving 3 years back to, or were trying out different approaches which are based on deep learning. So this is the first. I'll skip that in the interest of getting to the second. So the second approach, what they did was, again, take the question, create an embedding of the question, and maybe somebody else, after reading through this, I'm not yet 100% clear what the representation is and how that is different from the embedding, but let's skip that for a minute because it's more important to get to what you asked, Dinesh, and what this seems to provide a slightly different angle. It says that instead of just using cosine distance, they're using cosine distance and the angle between the vectors or the embeddings or the representation of the sentence embeddings that they are using or generating. So they refer to a paper as well that they based this technique or the second implementation technique that they adopted, which is based on generating an embedding and a representation and then finding the distance and the angle between the two representations, between the representation of Q1, question 1, and the representation of question 2. And that's the thing they refer to as you.
And angle is basically same as cosine similarity in a sense, right?
Yeah.
Yes.
Cosine distance is actually the angle. Yeah.
Right. But they also use the distance.
So that would be the something like the Euclidean distance, and the angle is
right,
basically the cosine similarity. Yeah.
Yeah. So I just wanted to point to this as directly one answer to Dinesh's question. Like besides, and of course, you know, Dinesh, as you pointed out, we could replace this with Jaccard distance module. We could do just the cosine, which would just be the angle, and then we could use this. So what it says is, hey, if you're building a solution for this Kaggle, maybe you make this a module so that you can slip in different ways by which you can judge equivalence or similarity or whatever, and then you build this piece separating, which anyways is happening because if you're using the sentence encoding or whatever, I think last week you had pointed to, you know, you may get different sentence representations, if you will, and then you have another module which kind of does this piece and then pass that through a couple of dense layers and then decide whether it's duplicate or not. So I thought this approach gave one slightly different answer to what Dinesh you were asking, and also is one of the three approaches that they refer to. And they have a paper, a social banning paper in the footnote, if I can. I think it's this guy. And by the way, just so you know, in the footnote, they also say that the original paper, which is this guy, represented a tree LSTM, but they use an even simpler model. So that could be one implementation we could try. Now, obviously, it's a little more complicated because you have to come up with the LSTM implementation, if you will. But on the other hand, you could also use the universal sentence encoding and just use or code up this part, throw in a couple of dense layers, build this model using the output of the representations or the output of the universal sentence encoding that Gautam pointed to generate the sentence encoding for the two questions, and build this model and then try out the output of that model. And what Gautam had done, I think, was pretty much had the red and the green thing here, and then this part here. Did you have any dense after, or were you just directly comparing the output of the angles, Gautam?
Yeah, it's just the cosine similarity, nothing else. Cosine similarity of the sentence representations.
So R1, R2 cosine similarity, but were you putting that output into any kind of further dense layers, or were you just directly using that output?
The cosine similarity is just a number, right? So here what they're doing is they're taking the dot product. Oh, given that's just a number. Yeah, I'm not sure how they are actually using that in a dense layer. That part is confusing still.
You're getting something from the left.
Yeah, so that's something which I was curious about. But that's just an example of how to proceed with something with even
the distance part is also a scalar, right? It's the magnitude of
yes, it is.
So how so they are just having two scalars.
No, R1 minus R2 doesn't need to be a scalar, right? It can still be a
it's
vector.
not the magnitude of that.
But this is magnitude.
And is that the magnitude? I'm not sure. Probably
or is that just the?
Yeah, if it is magnitude,
I thought
then
it was the magnitude when I referred to it.
But then it wouldn't make sense, right? You just have two numbers.
Right, even if it's magnitude, you still have two numbers. I mean, I don't see how there are multiple dense layers, but you can still squeeze in one dense layer for sure, right? You can concatenate these two and then you still use it.
No, that
Oh,
doesn't
by
make
the way,
sense.
to your
Two
point,
numbers and-
they are saying the angle is calculated as an element-wise multiplication of the two,
Okay,
which
okay.
would leave it as a vector.
Okay,
Right,
it's not
okay.
dot product then. Okay.
Yeah.
Yeah.
And the distance calculated as the sum of the squares of the difference of the two vectors. This would be a scalar, I would imagine then, right? Because it's the sum of the squares of the difference.
Yeah.
But you could, I'm sure you can look at the
That's the
paper because
Euclidean
they seem to
distance,
write.
right?
Sorry, Gautam?
Yeah, multiplication of elements is cosine similarity, isn't it? Oh, 1 minus. Actually, cosine is multiplication of elements, which is normalized.
Normalized, yeah.
Cosine,
Yeah.
By
yeah, cosine is dot product by product of the magnitude of vectors.
magnitude, correct.
Yeah. But this is
So it's a scalar divided by a
element
scalar, which is
wise.
a
Yeah, this is element wise multiplication, right? Yeah.
Isn't it?
yeah. So you would say this would result in a vector of length, assuming
the-
R1 and R2 same length, vector of length of that.
And what about the left one, the distance? Isn't it the element-wise subtraction?
It's the sum of
It
square of
says
it.
That's
here,
the Euclidean
and this
distance,
is
right?
where, yeah, because it's the sum of the square of the difference. But you don't take the square root, it seems like, because that would be the, wouldn't the square root be included in Euclidean distance, Gautam?
Yes.
Because here they don't seem to take the square root. So I think the details would be in the paper that they refer to as to what is exactly done. But again,
And Euclidean distance is the difference of the squares, I think, right? Yeah.
Yeah, is element-wise difference squared and then the square root of that.
Yeah,
correct?
yeah. So it's not.
And is that the one scalar number coming out then? R1 minus R2? One scalar? Or is it a vector coming out from here?
It would be a scalar.
One number.
Yeah, I would imagine.
Yeah,
so.
I believe in this case it's a scalar, but we'll have to look at the details to see how it's implemented. My guess is this would be, at least as described in words and as shown in this picture, it seems to be a scalar.
How is this different from Euclidean, sorry, other than the square root missing?
Square root missing was my point.
Oh, that's all right. Everything else is the same, right?
Yeah, sum of the square of the difference of the two vectors. So
right.
now the question is, when you say the difference of the two vectors, then you would take the individual element-wise difference, yeah.
Right.
And then square it and sum it, but the Euclidean would include a square root. And I don't know whether even in this case they do that. That's where the details in the paper are important.
You can think of the triangular vector thing that we studied early. I mean, in high school and stuff. It's it's basically the same as Euclidean. Yeah.
Yep. So actually, there would be no difference. You're saving yourself computation by not doing the square root, right?
Yeah.
There's nothing else.
So what's the dense layer 1 and 2 is doing then? What information it's spitting out then?
I would imagine that these had additional weights to manipulate the output that comes in from here. What I think Gautam and Rekal were discussing is, we need to look at the paper to determine what's the exact output, what's the nature of the shape and other things of the vector right at this arrow that goes into the dense layer 1. The dense layer 1 and 2 just do a full or a fully connected 2 layers, which add a bunch of weights to get you a better decision on why.
Okay.
Right, and what's the size of it and stuff, we could, you need to look at the paper to determine, and you can play with that. It could just be like whatever. But this is one implementation. Here is a simpler implementation. Again, as I said, as Yuri mentioned, and my apologies, I should have done more on this, and I will, since I'm encouraging everybody else, I fell short myself this week, and I'll try and correct that, do more. But I wasn't able to quite completely figure out. If any of you do figure that out, then please post. But I couldn't quite grasp what the representation did beyond the embedding. But ignore that for a minute. Then what this does, this model does compared to this guy, is the fact that it just concatenates it, puts it through an LSTM, and then comes up with a decision.
Representation is kind of like, from what I remember, is like a latent representation, right? So it's not going to be as big as what your original vector was, but it's going to be.
Thank you, Rachel. I think you just triggered something. Basically, the representation, the embedding is put into an LSTM. So the LSTM output is what they call the representation.
Right.
So the embeddings are fed into LSTMs, which then come up with the representation. And in this case, they just concatenate the two, throw it into a dense, and then make a decision.
I think you could just as replace that LSTM with attention, self-attention, and see what comes out. Maybe that could also.
All right, that is great, because that's, I think, what they did in the third approach. So it kind of also, that's excellent suggestion by Gata, because it just says, hey, at least we are thinking along the lines of these guys too. Right? And then they just do a comparison of the three approaches. But what's fascinating is, so we could try implementing each of these, or even just one of those to begin with, just concatenate, get the embeddings from the universal sentence encoder or from what Yuri pointed to, put it through LSTM, or put it through LSTM and then with this metric and a couple of dense layers, concatenate, throw the output into a dense layer, get the output, do this, or as Gautam has suggested, do attention-based approach to that instead of putting it through LSTM. And they refer to this decomposable attention paper for that, and all of the references are provided here.
Can we quickly go back to the attention figure? I'm just trying to wrap my head around what exactly are they putting in. So you're comparing the two sentences, calculate the attention scores across those, right? So what are those green arrows? Is that just a concatenation of each row?
These guys?
The ones like further to the left beside the table itself. Yeah, to start with, what are those green ones? So he's doing G, park, and outside. Does anyone have some idea of what exactly is going on there? Is this an added factor that he's adding attention also into it, or is this only attention? That's what I'm kind of trying to understand.
I think this is simply attention, right? Like you take the embeddings,
right?
You still have embeddings of the question. Then you apply the attention between the two questions, right? Word to word, word to every other word. between the two questions.
Have you seen something like this before? Attention across two sentences? Like, what are we trying to understand with that? Like, attention within a sentence, I can understand a certain word trying to pay like attention before or after, right?
Yeah,
sure. The encoder decoder attention, sorry, Gata, just a minute. The encoder, or sorry, the decoder encoder attention is across sentences, right? When you do the translation, because it's on the translated
right.
language, every word to the sentence you're translating, or to the sentence you're translating from language. Okay. Sorry, Gautam, go ahead.
Yeah, I was just so if you are having just self-attention, then you would still have an embedding for each word. You won't end up with one embedding for the whole sentence, right? So maybe just attention is not sufficient. You would, so like I think maybe Srinivas was saying encoder, decoder as well.
But here you're trying to do across sentences, right, Gautam? So self-attention would pretty much be within the sentence. You want to do across though, right? Does that make sense, or am I?
Yes, it does. In fact, if you look at this sentence record that they have, sorry, that was inadvertently funny, but the process shown in figure 3 trained an attention model for all pairs of words in the two questions.
Okay, right. Okay, that makes sense. Okay.
So every word from question 2 with every word in question 1, vice versa.
Right. Mm-hmm.
That is what I was referring to as decoder encoder attention, kind of.
Yes.
But in this case, right, because you're analogous to decoder encoder attention in NMT.
Right.
Because you're paying attention, you're using the query word as the word, in the future language that you're translating to, and your keys and values are in the, so translating it to this example, the query word would be a word from question 2, and the keys and the values will come from every word in question 1.
Mm-hmm.
And the only difference is in this case, they probably do it both ways. So that's meaning Q2 to Q1 with every word of Q2 being the query word, and then Q1 to Q2 with every question, every word of Q1 being the query word, and keys and values coming from Q2. And then how they combine that is the interesting, right, exactly, because they also then say finally aggregated comparison to get the classification result. But I guess that's this, but also how do they combine this attention? And I wanted to go back and look at this term soft alignment, because there is something as soft and hard alignment in attention, but I've forgotten what it is. Gautam or anyone else know?
Yeah, hard is when you attend to just one word, whereas soft is when you have a probabilistic distribution over all the words. I mean, that's basically it.
No, that makes sense. In which case here you are doing soft because you're doing across all of the words in the other question.
Yep. Okay. I mean, I don't think hard is used anywhere these days. It's always soft.
Yeah, because it's always soft. So then, right?
Yeah.
Maybe hard was an earlier version.
I think so. Now they have these newer models that are still soft, but you are limited to. I think this is what Sujit had talked about in the Transformers talk that he gave. So when you are trying to attend a word to a list of words, you limit yourself to a particular word and its neighbors while attending. You don't, so that you can save on that n squared complexity. You don't have to attend for each word to every other word. So it's still soft, but it's restricted in a way.
So it's like we discussed in 224, and it's like this top end. So it's like limiting the probability distribution. So you don't go across the sequence length. You go limited to some narrower distance from the word of interest.
Yep.
I see. How do you, I mean, do you recall or how that is determined?
So first of all, for each word in the decoder, they pick one word in the encoder side which is most relevant. Even that is trained somehow, I'm not sure. And then they take some neighbors around that word and they have a random Gaussian distribution. So that Gaussian distribution will tell you what is the attention. So the middle one would have the highest attention, and it would
and
like reduce in a normal distribution fashion. I mean, on either side of it.
Wow. Okay.
That's one way of doing that. Yeah.
Okay, that's good question, Rick. I think we may, how this implementation is done is something that we need to look at in the paper details. I think they refer to paper 4, specifically this guy. And I believe that's...
The scores look so similar across those 3 approaches.
Yeah, it's kind of interesting that their score is... That's one of the things I wanted to point out, that it's not...
Precision is... Okay, right. Sorry, yeah, I missed that line completely. Okay.
On an F1 score, they're almost, right? In fact, LSTM does better.
Right.
The decomposable attention part, it's only better here, right? On the recall score. Everything else actually is smaller compared to the distance and angle.
Yeah, interesting.
And also the distance and angle is not always better other than this guy, and maybe slightly better. So it doesn't seem, these two seem very comparable, just concatenating and taking the distance and angle. So it's kind of fascinating that multiple of these approaches all end up with very similar scores. And attention, while computationally maybe more obviously faster, doesn't give us, at least for this task, a heck of a lot better. So I just thought that these were 3 relatively modern compared to, just doing TF, IDF, or, and interest of time, since already over a few minutes, but I'll just take a couple of minutes. So these 3 approaches are something that hopefully, multiple of us can try using the encoding from the universal sentence encoder and then building out any one of these 3 models with the references. I thought that approach would be, any of these would be viable things to build out and see what happens and see whether we can duplicate the results that we get. Or even better, given that our universal sentence encoding might be a better thing than what they ended up using as part of their embedding, but maybe not. That's where it would be interesting.
Just a point on that. So if you end up using like a universal sentence encoder, I'm not familiar with that, but then won't you be kind of like jumping the step over here, like for the representation thingy?
But, the universal sentence encoder gives you an encoding from the question, correct?
Yes. So does that not give you just one embedding, Gautam, in your case?
Yeah, you're right. It would entirely skip over the LSTM part. It would directly give you the R1 and R2, I think. Yeah.
Right. Okay. Cool. Okay.
So probably not the best approach.
Yeah, I mean, if you're trying to learn, I would imagine, you want to squeeze in more things there. So it can.
So you're saying because it generates final vectors that you want to input here, even more rudimentary approaches to take the question, pass it into like a Glover word to X, then build LSTM for these representative pieces and then build out the rest of this. Is that right?
Right.
Yeah. I believe the embedding here is referring to word embeddings, and then
correct.
Yeah, combine them in a way using LSTM or something to get the R1.
Right.
I think the objective of the universal sentence one was just as a baseline. So it wasn't that we would build on that necessarily.
I mean, you could try that too.
Yeah,
also.
actually,
I'm just saying that you jump the representation step if you kind of end up using that.
Yeah, it's kind of interesting because if you look at this, they seem to have done it yet again slightly. So that's why it's this is fascinating. So there's so many different approaches. They train their own word embeddings. So it's like instead of using GLOVE or Word2Vec, they did their own thing using Cora's text corpus, which we can ignore, and let's say we use GLOVE or Word2Vec, and then see what they did. They combined them to generate question embeddings for the two questions.
Right. So we could also do the same thing. Get R1 through the LSTM and then use like the sentence encoder and concatenate that representation onto that. So yeah, there are like a bunch of ways we could experiment.
Right. Exactly. So that's what I was saying. I mean,
they don't talk about how they combine them to generate question embeddings?
Yeah, no, they don't, which is kind of sad because they don't tell us how they get from word embeddings from the question to sentence embedding. It just says combine them to generate question embeddings for the two questions.
Wouldn't that,
which is the reason that
wouldn't running it through the LSTM basically be the embedding for that question? I don't know how the sentence thing works, but I'm imagining like that's how it works. Right? You would start with the word level and then run it. Sorry?
Yeah, that would be the obvious way, yeah.
Yeah.
But they don't talk about it here, I guess.
Yeah, true.
Yeah, and of course, we can, this is just a blog post. There might be more details in the papers and or further references that I didn't chase down yet. But interestingly, right below that is another paper, which also refers to something very similar, and it gets comparable results, slightly better because it says 88.17 on the test set. And then I haven't gone to all the questions and or answers, but I just thought this was fascinating that there are 2-3 approaches that Quora itself has called out that we could try and see and see whether the results approximate what they got, and whether using any of the more modern sentence embedding types of stuff that Gautam and Yuri pointed to help us improve what they got if we were to start from that, as opposed to starting from word vectors, going through that embedding and then generating a representation and going the next step. I don't know which will end up being better, but I was just curious. Just wanted to share these 2-3 different things which I thought were interesting. Any questions or comments?
Just so I understand, the representation we think is a presentation of the sentence, and embeddings are embeddings for individual words. Is that true?
That's what it seems to say here, Yuri. Okay. It says we train our own word embeddings using Cora's text corpus. That means these embeddings are word embeddings trained by the Cora text corpus, right? And then combine them. Now, as Gautam and Tekil and I pointed out, how they combine, they don't at least share here. One way would be just by using an LSTM to generate the hidden representation at the end, much like you would do for a LSTM encoder. But they just say combine them, right? And then generated the representation, and then use 2 different approaches. One is concatenated the 2, put a lens layer, and then the other approach is this. And then the third one is doing
attention.
Attention.
Thank you.
Yeah, and then fed those question embeddings into a representation layer. See, that's where Gautam or Rakil, that I'm a little bit confused because of this statement. They feed question embeddings into a representation layer, which means they don't use the representation layer to generate the question embedding. They generate question embeddings and then feed them into the representation layer. That threw me off.
Right, I guess their layer, is that the LSTM part? I'm not sure, I need to read that. I'm just...
Yeah, so anyway, look at it and post. Yeah, read through it and post your thoughts, but at least that's the reason that I wasn't sure, as Gautam was asking, I wasn't sure how they got to, or they don't share, I should say, how they got to the question embeddings, which is the reason that then I was of the opinion that you short circuit everything before question embeddings by just taking the question embeddings, by providing the input of the question into Gautam's universal sentence encoding and get out a question embedding, and then use an LSTM and stuff to generate these representations and then do the rest.
But how would you feed a question embedding to an LSTM? You already have the whole sentence embedded into a vector, right?
Correct. Yeah, that's what my question.
You would need a word-wise representation.
You have to be at the word level. I mean, conceptually, I think the way, like Yuri was pointing out, is like embedding is at the word level and representation will be at the sentence level. And how they get from one to the other, I would imagine you have to squeeze the LSTM between those two. You're trying to represent the whole sentence as a vector. In essence, like the representation one would be the output of the sentence encoded.
Yeah, that makes sense what you're saying, and that's why maybe I'm reading too much into.
Yeah, that representation layer is kind of confusing when you say feeding into that. Yeah, I'm also not sure.
That sentence confused me or threw me off. That's why I was saying I have to think through that. But what you're saying makes sense because there is just one embedding. So what are you feeding to the subsequent steps in the LSTM, right? So. Okay, let's give any of these approaches and or even your simpler other approaches a thought, and we'll have a follow-up on whether and how people have performed. But again, one last thing, if I might, because the topic came up, there was, I should say, before Quora posted these, there was also this concept of skip text and skip thought vectors, which were apparently the thing used to form better what we now call sentence encoding. I haven't gone through the blog post and so on. This week was busy and I was distracted for various other reasons, but here I'll post the references since the skip thought vectors came up in the CS224N discussion as well. Here's a blog post on them, and they are used, they were, I should say, used extensively in determining the semantics of a particular sentence, which means the meaning of the sentence. And ultimately, when we are making a decision on whether two sentences or two questions in this case are duplicates or not, we are interested in whether the two sentences mean the same thing or not. So that's why the skip thought vectors were used quite a bit before. These preceded, you can see the date, it's 2016 October, so it was before the Quora post and stuff, before all the transformers and stuff existed. The skip thought vectors were the way by which the semantic equivalence of two sentences was evaluated. So I'll post the links to that, but that I thought was, I don't believe too many people are using the, sorry, this isn't the one, this is, are using skip.vectors now, but seems in the historical progress of the field, the skip.vectors were relevant in generating semantics of a sentence. Since the topic came up, and there's a couple of more bookmarks in my tabs that I'll combine and post. So that is another approach that if people are interested in trying, they can look into it. Obviously, that predates transformers and BERT and even, I believe, kind of the LSTM concatenation approaches that Quora posted.
One quick question for people who have submitted, what kind of time range are we talking of for a submission if you're running through the whole data?
Sorry, what do you mean by time range?
Like how long does it take, like if you were to train the whole network on, train the network on the whole data?
It's quick.
That's quick. Okay.
Couple of minutes more.
Okay.
Like it's more of like uploading a file.
Right.
But once you have done it, it calculates very quickly.
Cool. Sounds good. Thanks.
One thing which I noticed, it doesn't show you your positioning. So I'm not sure like if it's the, I have done one or two past expired Kaggle computation, but whenever you click on like your position in the computation, it brings you to your position. But for me, in this case, it's not showing my position whatsoever. So I'm not sure if that's the...
Yeah, no, Dinesh, I had the same experience. It does not, yes, your experience is what I had too. When I submitted, it gave me the private and public leaderboard score. Typically, like you said, in other competition, it adds you to that list that it has. In this case, it didn't.
Yeah.
So yeah, like so your experience is what I did.
Yeah, and it looks like it doesn't even add you anywhere in a list. It's just your score. It's going to get displayed because I scroll down all the way, trying to find where do I sit. I should know it. It's just outside.
Yeah, no, you're right. It didn't for me either. So it's not just unique to you. It for this competition, it just spits out the score. It doesn't place you on the list.
Okay.
But you know, just out of curiosity, I found out that if you wanted to be in the top 10%, I think your score ought to be of existing scores. Obviously, it is 3 years old. I think it is like you have to score better than 0.15 something.
Correct. Yeah.
So 0.15xx is the bottom of the 10 percentile. So if you want to be in the top 10%, your score result should be better than 0.15. I think the best recorded, if I recall correctly, is like 0.11xx. So kind of good goals to have to work towards over the next several weeks. Any questions, comments? Hopefully more of us would have made more progress this week. Good luck to everybody. I'll post on Slack and also send out the discourse link and the recording as well. Thanks everybody for contributing, participating. I encourage more of you to try different things, submit. Even though, as Dinesh and I said, you may not see your name in the results, but you'll get the score back pretty quickly. All right. Thanks, everybody.